Conceptual Geometry, Unit 9, Day 5, Angles with Intersecting Chords. This is one of the more challenging angles that we have to find in a circle because it's not central, it's not inscribed. First thing I'd like you to do is just draw two random chords that intersect inside the circle, but not necessarily in the middle. So it's not a central angle. All right, this one gets confused with a central angle all the time. Then I want you to highlight the two arcs on the opposite sides of that angle. And maybe here we can label this arc 1, and then over here arc 2. This is called an angle formed by two intercepting chords, and that angle is equal to 1/2 arc 1 plus arc 2. Now when you add two things up and divide by 2, it's finding the average. So you can think of it as the average of the arcs. All right, our first example here, we can see the angle we need to find. It's not central. It's formed by those two chords. And as long as we know this formula, it's pretty straightforward. So here we go. The angle x equals 1/2 parentheses 102 plus 80. Now, obviously, you can use your calculator on this, and I would expect you to put all of that right into the calculator. You can put a 0.5 in for your 1/2. But if I add those two up, I get 182. Divide that by 2, 91. Skipping the next one, let's go right to the one on the right here. This is a very similar situation. There's my angle formed by the two chords. Here are my two arcs. So to find x, I take 1/2, because I'm finding the average. 85 plus 75. I add those up, I get 160. Divide that by 2, and that would be 80 degrees. The one in the middle is a little bit different because I give you the angle. You know the angle's 30, and I'm trying to find this arc here, and the other arc is 40. Well, if we're finding the average of two numbers, you guys probably notice that there is a pattern. And here's the pattern, kind of like we did with a midpoint. I go from 40 to the angle to the arc, and I look at what we did each time. So going from 40 to 30, I subtracted 10, which means going from 30 to x, you also have to subtract 10. So x equals 30 minus 10, or 20. And I just find that to be the easiest method for finding the arc when I give you the angle. So in the next one down here, I want to apply that same concept we just talked about, the pattern. So here's the angle, that's 150, and then here's the other arc we need to find. So I ask myself, going from 200 to 150, what did I do? I subtracted 50. So then going from 150 to x, you have to subtract 50. So x is simply 150 minus 50, or 100. And it's easy to check when you're done because you just have to make sure that 150 is the average of 100 and 200, or is it exactly in between 100 and 200? And yes, it is. I'm going to skip the middle one, come back to it in a second because it's harder than this last one. Applying the pattern once again. If you need to find the arc, it's basically at the end of the sequence. So here I went from 130 to 110 and I subtracted 20. Sometimes you add, sometimes you subtract. I know all the ones we've done so far we've subtracted, but you could be adding as well. And then from 110, I would need to subtract 20. So x equals 110 minus 20, and that's 90. Now the middle one is real tricky. Here's why. X represents this angle here. But if you notice, I'm given these arcs. I cannot use these arcs to get x. So this is one of those questions where you can't use a formula directly to find x. You'd have to find a different variable, call this one y, and then recognize that x and y add up to 180. So to find y, I would use the formula from up above. Y equals 1/2, 170 plus 40. So 170 plus 40 is 210. Divide that by 2, I get 105. Now to find x, you take 180 minus 105, 75 degrees. That is one of the most challenging problems you can have in this circle unit. Okay, so on the second page, I need to find w, I need to find x, I need to find z, I need to find y. What I like to do for the most part is find the arcs first. Usually that's the simplest. I know this arc here is 68. I know that arc is 75. I know that arc is 90. So what I'm going to do first is find w. Because I know all the arcs of a circle add up to 360, exactly. So to find w, I'm going to take 360 minus 90 minus 75 minus 68. So that equals 127. That's this arc here. That's w. I got that part. Now with the intersection in the middle, I'm going to apply the formula we just learned just one time because I know I have vertical angles and supplementary angles. So I don't care which one we find first. I'll probably find x. That's going to equal 1/2 of the opposite arcs. So that's 68 plus 90. Throw all of that into the calculator. That's 158. Divide by 2. I believe that's 79 degrees. So x is 79 degrees, and then I'm pretty much home free. Because if x is 79, y is 79, vertical angles are equal. And then to get z, you just have to subtract 79 from 180. I got 101. All right, example 2. One thing I noticed right here, x is going to be 64 degrees. I noticed that right away because it's a vertical angle with the 64-degree angle. And then I need to apply this pattern, 42 to 64 to y. So 42 plus 22 is 64. And 64 plus 22 is going to be 86. And that's your y. So this arc here is 86. And then finally, to get the last arc, you know that one's 42, you know that one's 80, you know that one's 86. All it's left for me to do is find z. And I can find that by taking 360 minus 42 minus 80 minus 86. And that equals 152. All right, the last of the smaller examples before we do a big circle question. Pretty similar to the one right above it. You know 3 arcs. First thing I'm going to do is find the missing arc by taking 360 minus 110 minus 80 minus 70. And that equals 100. So y equals 100 degrees. Now the next one, you can find either one, x or z. You have to find one of them using the formula. I'm going to find x, which means I need to use these 2 arcs here. So x equals 1/2, 80 plus 100. That's 180. Half of 180 is 90. So if x is 90, that means that's a right angle. That means z is also going to be 90. 180 minus 90 is 90. All right, and the last question here. We got a lot going on. It's very wordy, but just look at the arcs that were given. So generally when I see this problem, I don't even worry about finding these angles or parts A, B, C, D in that order. I look at my diagram and I see I have all the arcs except for one. And that's the first thing I'm going to do is find that arc. I don't care if it's step 1 or step 5. I need to find that first. So I'll take 360, minus 80, minus 70, minus 90. And that equals 120. So this arc here is 120. Next, I look for central angles, which means the vertex is on the center. I don't have any of those, unfortunately. So now I do inscribed angles. Again, I'm not really paying attention to what's over here on the right. I recognize, oh, if I have an inscribed angle, that's going to be half the arc. So here's an inscribed angle. Half of 70, that's 35. Notice there's another inscribed angle that goes to 70 degrees, and that one's down here. So that has to be the same. That's going to be 35. And then I'll use a different color. I've got this inscribed angle here, which is half of the yellow arc. So that means that's got to be 60. And then, check it out, there's another inscribed angle that goes to that same arc. So that has to be 60. So now I've got an arc, I've got a bunch of angles. Let's see what I need to find, and if I found it. Angle BAC. Well, I haven't found that one yet, so I'll skip it for now. BAC. There's got to be a way to find that. We'll get to it in a second. Angle BDC. Yeah, I found that one. BDC is 60. Angle CFE. Haven't found it yet. I'll be able to find that in a second. Arc BC. Yep, that's 120. Angle AEB. I haven't found it, but it's pretty easy to get. Here's angle AEB. What I notice is it forms a straight line with that angle right there. So this is simply going to be 180 minus 60. Put it in the figure. It really helps to put these angles in the figure. So now I know I risk cluttering this up, but I'm going to highlight two shapes that will help us find these angles I haven't found yet. First one is angle BAC. Let me highlight a triangle for BAC. Angle BAC is up here. It's part of that yellow triangle. We should know at this point that the three angles of a triangle add up to 180. So to get this angle here, we take 180 minus 120, which is 60, minus 35, and that equals 25. So that angle up there is 25 degrees. And now I'm going to highlight a different triangle for angle CFE. I'll use green for this one. So to get that angle, I just need to take 180 minus 60, which is 120, minus 35, which I believe is 85. All right, that concludes the notes for day 5.